I think we're doing 3.4 and 3.5, and I'm gonna have to pull up some stuff from Moodle for this. You can go shut the door. All right, today, let me share the screen real quick. Share screen. All right, so today, this is from last week. We didn't meet. I wanted you guys Thursday to look over 3.3 folder and finish that. You guys go ahead and do that. 3.2 and 3.23. So today, 3.4 and 3.5 is what I'm going to cover today. So 3.4, we're going to go over these. Take a look at these parent graphs first. So 3.4 is going over piecewise functions. I'm going to do a couple of examples with you guys today, just kind of going back over that. And then 3.5 is covering transformations. The next week, which will open tomorrow, you will have a test on chapter 3, and then you will have several things in chapter 4 to cover for next week. But again, I would have all of this printed out for chapter 3 when you do your test. Go ahead and have all your notes and things ready to go when you do your chapter 3 test. So parent functions, you kind of need to know these for when you are, can you see that okay?
Yeah.
You can see it on yours.
Yeah.
All right. You need to know the hardest thing for parent functions and piecewise functions is just knowing what kind of function it is. A constant function, this is just a linear function that just goes straight across like a horizontal line. Your linear function is, y equals x or f of x equals x. Absolute value is always going to look like a v. So you can move this up or down. Greatest integer, we're not really going to cover, but this is what one looks like. We've talked about quadratic functions already. This is where you have your f of x equals x squared. This just goes through the origin, but obviously you can move this right or left, up or down. Cubic function, we haven't done a ton of these, but this is what one looks like. We have talked about them. Square root function, we've done radical functions already. Cube root looks like this. And then we haven't not talked about exponential logarithmic. We have talked about reciprocal or just, well, it's pretty much the same as a rational function, but they look a little different. But we have done rational functions a little bit, not really graphing them. And then these three are going to be talked about in trig, the trig class 172. I'm going to take that class. So we're not going to do those three. So here's a nice little video that Mr. Price did on piecewise, and here's another video going over piecewise. Here's another one going over piecewise. I'm going to do a couple more examples. And then 3.5, this is another note sheet that I would print out. This is still going back over piecewise functions, parent functions. This one actually talks about the domains of these though. So remember we talked about the domain, what's being covered on the x values, and then the range is what's being covered on the y. For linear function, your domain is always going to be all real numbers and your range, except for a vertical line is the only difference. Domain for a quadratic is all real numbers. The range is greater than 0. Cubic is all real numbers for both. The square root one domain has got to be greater than 0, and then the range is also greater than 0. Reciprocal is pretty much everything but x equals 0, which is what that states here. Here's absolute value. Domain's all real numbers. Range is greater than 0. Greatest integer is domain is all real numbers, and the range is pretty much all integer numbers. All right, and then this is the part for 3.5. I'm going to get to this in just a minute, but I would print all this out so you have it for your test specifically. And then this one kind of gives some examples. But let's just look at some notes first, and then we'll go through some of the 3.5 stuff. Stop sharing. Did I stop sharing?
Yes.
Okay. All right. did 3.3 with you guys, because that was a long section. 3.4, let's just do some. All right. 3.4 piecewise. And all a piecewise function is just more than one function on a graph. That's all it is. So let's say we have f of x. Two x plus 1. All right, so this is an example of what a piecewise look like. Notice we have 3 equations, 3 different equations. And what's on the right-hand side, this is technically what's telling you the domain of each of the functions. This is technically the domain. Okay. And my suggestion is to do a table for these, which would make it to graph it easier. And I would also go ahead and look at each of these and determine what kind of function is it. So what kind of function is x squared? What kind of, when I say function, I mean equation. What kind of equation is it? X squared. You guys should be able to spit it out. Is it linear? Is it exponential? Is it quadratic? Is it cubic? Is it rational? It's not exponential.
Right.
Quadratic. Exponential is when it's to the power x. Okay, so quadratic is when you have gonna be a square there. All right. So think quadratic like that, right? So if I do a table, my functions, this is telling you x squared is.
Here. She's on.
Oh, perfect. I gotcha. Okay. So we're looking at fx is equal to x squared on this one. And we want it where x is less than 0 for your domain. So that means everything in the x value is going to be less than 0. So I'm going to start with 0, and then I want numbers that are less than that. So you can just come up with numbers. Now, obviously, this is not in the correct order because normally we go opposite, but it really doesn't matter for this. So when I do my graph, it says less than 0. So am I going to include 0 or do I not include 0? Not include 0. So that means it's going to be an open circle here. So I'm not going to include 0. I'm putting it here just for the sake of graphing. So we still have to put 0 in here, but we're going to have an open circle on that number. So when we plug 0 in, 0 squared is going to be 0. So when I graph this, on 0, 0 is going to be an open circle here. We're not including 0, but I technically still have to start there. And then I want numbers that are less than 0. So I'm going to plug in a -1 here. A -1 squared would be +1. A -2 squared would be +4. And a -3 squared would be a +9.
No.
So think squared is meaning 2 times 2 or 3 times 3. So we would do -1, 1 would be here. We would do -2, 4 would be here. We would do -3, 4, 5, 6, 7, 8, 9 would be up here. And you can kind of see our graph is curving up. Now, if we had the entire graph, it would be something like that, right? But we're not including that because we only want the numbers that are less than 0. So that's my first graph. The next one is f of x equals 2. What is that? What does that mean? What kind of graph is it going to be? That means y is equal to 2. What kind of graph would that be? A linear. It is linear, yes. It would also be a constant because every value of y is 2. Does that make sense? We're saying x is equal to 0. So, we have x and f of x, and we want our value of, x to be equal to 0, and we want our y value to be 2. Does that make sense? So 0, 2 is just gonna be a point here. Now, technically, if I were to graph y equals 2, it would look something like this. If that makes sense, it would be a line. If you put f of x equals 2, it would be y equals 2. It would be a line. But because we have this x equals 0, we only want this point here. Does that make sense? Everybody getting this in their book? All right, that's for that one. It's linear. All right, the last one is what? 2x plus 1. F of x equals 2x plus 1. What is that? What is that equation? 2x plus 1. F of x equals 2x plus 1. Linear, also another linear. And this time we want x values that are greater than 0. Still have to start with 0, but then I want greater than 0. So that would be 1, 2, 3, and so on, right? Or I wanted to keep going, I could keep going. Now, on 0, are we including 0 or not?
No.
No, if it was including, it would have an equal to, right? So it doesn't have an equal to, so we're not including, so is it gonna be an open or closed circle? Open. Okay, I'm gonna plug in 0 there. 2 times 0 is 0, plus 1 would be 1. So 0, 1 is right here, and this will be an open circle. Now I'm gonna plug in a 1. 2 times 1 is 2, plus 1 is 3. So 1, 3. Here. 2 times 2 is 4, plus 1 is 5. 2, 5, 2, 3, 4, 5. All right, 3, 2 times 3 is 6, 6 plus 1 is 7. Okay, so we can kind of see it. Do you guys see the line? There's the line. That is a piecewise function. Everything on here is a function, because if I did the vertical line test, it would still work. Why does this one work here? If I did the vertical line test right here, why does that one work? Because the circles, right. If these were closed in, it would work. But these are open here, so that means it only crosses still one time right here, okay? Just be very careful with this description, okay? You have to know when you have to open or close. So really the only one that you're including here is on that 0 right here. If I draw a vertical line anywhere else, it's all gonna work. Everything works. So really piecewise isn't new. It's just kind of combining everything we've learned in one section. Are we ready to try one on our own? I think the tables are nice to separate them and then graph because it really helps you cover everything. Now, I think you can do this on Desmos. Let's take a look. I might try it. I don't know if it'll work. Again, I'm not as comfortable with Desmos as other, like Mr. Reason's really good with Desmos. So we're gonna do, well, what we can do is we can graph them one at a time. I know. Here. Graph that. Nope. Okay. I don't know how to do this. Cannot use an inequality here. Okay, well, we might not be able to do it on Desmos. Notice here though, we're doing x is less than 0, so this is that part here. We can at least graph, it's just not gonna have the domain restrictions on there. I mean, it kind of looks like that, but the only problem is there's no domain restrictions. There's gotta be a way to do it.
Settings,
Huh?
settings or something?
Here?
Maybe. Thank you.
Okay. I don't know. I'm gonna have to research that, because there's gotta be a way that you can do something. I will, do some research to see if I can figure that out, and write myself a note. So look for domain restrictions. That's nice. All right, let's give you guys one to try anyway. All right.
Oh, Jan's here.
Um,
She, I think she's here. He just, I just.
well, he was here earlier. It just keeps giving him out. He must be on a different email too. I think that's what it is. I think when you're not on the school email, it
Kicks you out of
kicks you out. But it should do that, because if you had the link, it should work. All right, f of x. All right, I want you guys to try this one. First, start out with your table. And then graph. Make sure you look at the domain restriction when you're doing the table. Like it's still saying admitting. Even if the internet's not working here, great either. Chance is there with you guys, right? Is Chance there?
You want us to grab it, right?
Yes. Is he using his school email? Yes, do the table first and then graph it. Latrell said, I think you have to put the X less than 0 in the second tab. I don't think that's gonna. Google it while y'all.
I got a question about how to grab these ones.
No one wants to say you love. But when?
Are you done?
Nearly,
Huh?
nearly.
Yeah. Okay. All right, so first one, what kind of equation is this f of x equals negative 3x? Linear. All right, we want x is less than -1, so that means I'm gonna start with -1. And is it gonna be an open or closed circle on -1? Open, because it does not have equal to. And I want numbers that are less than -1, so what would be in my table with it? What are some other? -2, -3, -4, okay, so I'm gonna stop there though.
Yeah, -4 goes all the way to 12.
Oh, okay, yeah, my graph's kind of pretty big. You see it right here?
Yeah.
So -1, and plug in a -1, that's gonna be a +3. Plug in a -2, that's gonna be a +6. Plug in -3, it's gonna be a +9. Plug in -4, it's gonna be a +12. So open on -1, +3, it's gonna be open there. Then 2, 6, gonna be up here. Then 3, 9, is gonna be up here. Then 4, 12 is up here. Straight line. Like that. All right, what about 0? That would technically be a constant on 0, but we're looking at just equal to I got these fixed. Yeah, no, that's right. Equal to -1. So 0, -1, there's gonna be a closed circle there. I got that one, just a point. And then the last one is what kind of equation? It's a quadratic, we've got 2x squared plus 1. We want numbers that are greater than -1. Is it going to be an open or circle, open or closed? How do you know if it's open or closed? Good question, Samantha. How do you know if it's open or closed? On this, if it does not have an equal to symbol on it, it's going to be open. So if you have a less than or greater than, it's going to be open. If it has a less than or equal to or greater than equal to, it's going to be closed. And if it's just equal to, it's also going to be closed, okay? That makes sense? So now I'm saying Samantha is in the lobby. All right, so -1, we want numbers that are greater than -1, so what would that be? 1, I would do 0 also, 1, 2, we'll stop there, okay? I plug in -1, so I've got 2 times -1 squared plus 1. That would be a -1 squared is 1, so 2 times 1 is 2, 2 plus 1 is 3. So -1, +3, that's gonna be closed. Wait, is it gonna be closed? Nope, gonna be open. We already have that one. Already open, okay? And then, I forgot to put the word, and then here. All right, 0, 2 times 0 squared is 0 plus 1 is 1. So 0, 1 is gonna be closed there. Those are just regular points. Plug it in 1, 1 squared is 1, 1 times 2 is 2, plus 1 is 3. 1, 3, we're going back up, y'all see it? Going back up, we're curving, so it looks like this, part of my quadratic. And then the last one, 2 squared is 4, 4 times 2 is 8, 8 plus 1 is 9. 2, 9. Here, like that. Questions? Now, I'm going to show this video on how to graph these in Desmos. I just tried it, it didn't work, but maybe y'all can help me. So I'm going to share screen, because I do want y'all to know how to do this in Desmos if we can figure it out. For those of you that don't have a graphing calculator. There is a way to do it with the graphing calculator, but it is missed. Y'all see this?
Piecewise functions in Desmos, so that's what I was gonna do for you real quick, is give you a demonstration on just how that works. So what you wanna do is you wanna come down here and let's declare this to be f of x. All right, and we'll say f of x is equal to, we'll open up our step brackets and we'll give it a region first. So even though this is the first part we see when we're reading function notation, our piecewise function, that is, this is what we're going to put in first. So we're going to say our function in this region. So when x is less than or equal to, you actually type in the less than symbol and then just press equals on your keyboard and make that less than or equal to. So when f of x is less than or equal to 1, I'm going to hit shift colon.
Should be a negative.
And now I'm going to describe how do I get the y coordinate. So according to this, I square the x multiplied by 3, so 3x squared.
That should be a -1.
And then I subtract 2x, so it's 2x. Then I add 1 plus 1. All right. And so in this region, x is less than or equal to 1. Oops, that should be -1.
Thank you.
I get this function 3x squared minus 2x plus 1 and zoom out a little bit so we can see that guy. Now, let me load this up again so we can see it. Okay, now that's the first region. Now I'm gonna go in here after the one, right here. I'm gonna press the comma,
Okay.
and now I'm gonna give it this next region. So from -1 is less than x, less than -2. Colon again. I just hit 5.
All right, y'all with me? Do we got it? Okay, y'all
5,
think y'all can help me remember this?
and then comma.
All right, I'm gonna stop. So we do the first part, colon, equation, comma. First, the domain part, colon, equation, comma. Okay, y'all help me remember this now.
Yeah.
All right, stop sharing. Actually, no, not stop sharing. All right, so let's do the first one. It was f of x equals
Mm-hmm.
squiggly.
Yeah.
And then we're gonna do the one we just did, so negative, no, we gotta do x is less than -1, colon, and then the equation, -3x. Then what do we do? Comma,
Comma.
all right, then
Domain.
x is equal to -1, colon, 0, comma. X is greater than -1, colon, 2x squared plus 1. Can we close it?
Yeah.
Yes. Okay. Is it showing us? Let's go out. I don't see it. Do I not?
It doesn't end.
I don't see it. Why does it look like that?
Because it doesn't, it's not a.
I know, but it's not showing the other stuff.
Yeah.
I mean, it looked like it connected all together.
Well, you're right, but let me see.
Well,
if I can-
typing it is these pieces and pieces and add together.
And why, okay. Okay. It's looking a little bit better, but it doesn't really show the. I mean, I think it's showing. I mean, it's still not showing the other stuff though. It like puts it all in one, like,
Maybe you could just do it one at a time.
yeah, let's try that. Good idea. All right. This,
Wait.
okay. And it's gonna show in a different color, which will be nice. Squiggly, what is it? 0,
Now you gotta do X.
Domain
equals -1, colon, 0. Quickly. Not showing that. X is greater than -1, colon, 2x squared plus 1. Quickly.
Are you seeing the purple and blue edge?
Yeah, at least you can see the difference in that. So maybe that would be my suggestion, is to, and I'm guessing it's just not showing the other. I don't know why.
We got you now. Might be at the top.
Well, it would be right here at this, it would be right here technically, but they're just not showing that. Anyway, questions on this? Everybody getting it? Okay. At least you know how to do it now. You remember that.
I don't use that.
That's why it's okay. There is a way to do it in the graph calculations, complicated. So it really, by the time you do this by hand, it would be the quickest thing to do.
Just do that.
All right. Transformations is the last thing that I wanted to talk about, is 3.5. There is rules for the transformations. I'm going to share that with you again from Moodle. let's go back and look at that again. I would print this out. So you have. Gosh, it's hard to believe it's almost November. And we're over halfway, guys. Over halfway.
Yippee.
Only have 8 weeks left. No, six more weeks. We'll have 6 more weeks left. I mean-
Talk to my advisor to,
Figure out classes, yeah.
yeah.
Yeah, I would definitely, it's registration time, so if you have, which most of y'all were in high school, so, I mean, you were too, but yours is a little different.
It's a weird.
Yeah, yours is a little
I
different.
hate explaining it out to people.
Yeah,
It takes forever.
here we go. So here is the steps for transformations, okay? For any function, if you want to move the function up, or if something's added or subtracted, that means you're moving it up or down, okay? Plus means you move it up, minus means you move it down, okay? Horizontal, meaning move it to the right or left, is gonna be on the inside of the function, and it's kind of the opposite of what you think. If it's negative, means you move it to the right, and if it's positive, means you move it to the left, okay? A reflection, if you multiply it by a negative, it's gonna flip it over the x-axis. If you input a negative into the function, it's gonna reflect it over the y-axis. And some of these you can just look at, trial and error, you can put them in Desmos and look at them to see what happens. Dilation means it's making it wider vertically or compressing it vertically, depending on what it is. If you're multiplying it by a whole number greater than 1, you're expanding, it's going wider vertically. And if you're multiplying by a fraction, it's condensing it vertically. And then the same thing, if you're inputting it, inputting a multiplication in there, you're compressing it horizontally and then expanding it. So that's pretty much the rule. So, for example, if you look at this one, x minus 1 all to the second power, you want to figure out what the transformation is. Notice this is on the inside. The hardest thing is to figure out the parent function first. Let's just do some of these without me sharing this. All right. And this is 3.5. I would print that out.
You have the furniture in here, or do you have the?
You go to the library. I don't know if they might charge you better.
No, they won't.
They don't.
No.
Okay.
Yes, how many times?
That's awesome. Good. I didn't want them to charge you. I was hoping they would charge you. But yeah.
It was like, you know.
If you go to Bill 2, that I think you can print. anything you want.
And I just don't wanna do, I wanna do it before I get home.
I will do that for sure. I'm not gonna go. All right, write these down, then we'll talk about the transformation steps.
Like on the second.
Yeah, I just added that. Now, you could just graph these in the graphic calculator and easily be able to, you can kind of do it piece by piece to figure out the steps. But I do want you guys to know how to do it.
Brain's not fun today.
Oh, it's one of those days.
Yeah.
I thought it was every day.
About the absolute value of the one.
No, yeah, that's the absolute value, guys. On the second example. All right, we ready? So we're gonna break this up piece by piece. The first thing you have to do is figure out the parent function. And that's why we do this. Figure it out. Figure it out. Gotta figure it out. Gotta figure it out, and which my 2-year-old would say like that. Go figure it out, or figure it out. Oh, he always misses the first syllable on a lot of the words. Kind of cute and funny, but. And he calls, my daughter's name is Maddie, like with 2 T's, and he calls her Maggie, Maggie, Maggie. So we call her Maggie now because that's what it sounds like he's calling her. All right, anybody got an idea what is the parent function? So if we kind of got rid of all the steps, what will we start out with? What are we looking at? And this is the hardest part with these.
Just multiply it out, let's see.
Well, imagine you got rid of all this stuff, right? You got rid of this, got rid of this, got rid of that.
Quadratic.
It's a quadratic, good, which is f of x equals x squared, okay? Think of parent functions like what you start with. All the other stuff's extra, okay? Now we're looking at our steps. We got a lot of stuff going on. We added in this minus 2 here. We got a +4 on the outside, and we have this 2. So technically, we've got 3 things that are going on. It really doesn't matter which one you do first. What do y'all want to look at first? The 4, okay? So imagine if you had x squared plus 4. This is on the outside, right? So is this a vertical up and down shift, or is this a horizontal shift moving to the right and left? Do you remember? Vertical. Good guess. Okay. Why is it vertical? Because it's on the outside. Inside is horizontal. Okay. So vertical is the easy one because whatever it says is what you do. If you're doing +4, that means you go up 4. Okay. So the first step then, if we're doing this +4, means up 4. We're moving it up 4. So imagine here's our regular parent function. Let's do this in red, right? You know where that one is? When we do the up +4, that means we're moving it up 4. So here it goes. It's the same function, but we just move it up. Does that make sense? All right, what's our next step? We want to look at the inside? Sure. Okay. So next, that's step 1. Step 2, we're going to look at the inside. We're adding in this x minus 2 squared, and we already did that +4. On the inside is horizontal shift. If you look back at the rules, it's kind of opposite than what you think.
So that one goes this way.
Right, it's gonna go to the right too. So even though it's a negative, you're gonna go to the right too, right? So this means right 2. So here I am, look up here, I'm going now, moving this to the right, let's do it in a different color.
So you're just moving the whole thing.
Moving the whole thing over by 2. Just being moved over. Now, again, the calculator does all this for you. It gives you the finished graph, right? I'm just trying to show you how it happens. These are called the transformations. Now, the last step here is we're multiplying this by 2. Now, these can be a little bit confusing. And if you do get confused on these, just graph it, see what it does to it, okay? This is where it's moving the shape of the parabola. When you're multiplying it by +2, that is when reflection. This is where you can expand vertically. So imagine you have this, how do you think of it? Imagine you have this parabola, just look at the bottom part, okay? Okay, here's my parabola, imagine that, right? And I'm multiplying it by 2. okay, which is greater than 1. And when it says when you do that, means you're just going to stretch it vertically. So that means I'm pulling this up. So what is it going to do? It's going to be closer. It's going to be narrower by 2. Okay. So that means like kind of splitting it in half. So imagine this now becomes half of that. Does that make sense?
Yeah.
Going to be narrowed. Okay. So we can say, we would say stretch vertically. By 2. And then we're done. This is our finished product. This one will be our finished product. Questions on that? All right, let's go ahead to this one. This one, I've got a +1 on the inside. Now, first of all, what's a parent function? Anybody tell me what the parent is on this one? What's those bars tell you? What was the one that had the bars on it? What are these in math that have 2 bars?
Absolute value.
Absolute value, thank you. So f of x equals absolute value of x. That's our parent function. Now remember, that looks like a v, straight v. Okay? So now we're adding 1 on the inside. So the first step is to do what? If I'm adding 1 on the inside, is that a horizontal or vertical shift? Nurse, but y'all with me? If you're adding 1 on the inside, is it a horizontal or vertical shift? Left or right? It's left or right, which is horizontal. And we're going to go left 1. Good. Okay, so this moves to the left 1. It's not going to change the shape. We're just moving it over 1. Now I have a negative, which tells you it's going to flip over the x-axis. Well, you're just flipping it. And it makes it look like that. Yes, so here, it's going to look like this now. Does that make sense?
Yeah.
So that's the last step. Step 2, reflect over x. All right, this one is our last one. I'm running out of time. I got 1 minute. Anybody know the parent function? Yep. Cubic, which looks like that. And then the only thing I'm doing to it is I'm doing what? +2,
Moving it over.
not over. Up.
Moving it up.
Now, see the difference? I want you to see the difference. This would be over, right or left. This means
Just up.
up. So step 1, the only thing we're doing is moving it up by 2.
Okay.
1, 2. See the difference? Yeah. But that.
Mhm.
It's not hard stuff. And again, you can use the calculator. You could do each of these step by step and just look at it and see what it does. If you forget steps,
Uh-oh.
especially the stretching vertically, and that part is hard to tell. And you forget.
That teacher used to do it all the time. Can't see the cat. No, this
Oh,
is-
goodness.
You had to look at it.
Well, in today's world, you're gonna be able to use a calculator,
Yeah.
you know?
So
So-
that brought back memories of actually looking at every equation problem, just figuring out just by looking at it.
Yeah, and now y'all have AI. So like,
I don't try
I mean,
to
you
do
could probably put, and I wouldn't trust it either, because especially for math, there's some weird stuff that it does. I mean, I do want you to know how to do this, but I'm just saying, in today's world, you guys have so much technology, you need to learn how to use the technology to help you. But as long as you know this process and then you want to use the calculator to check your answer, I'm happy with that. All right, questions? So tonight, there's a discussion that needs to be done. There is 2 quizzes, okay? Everybody got it? Is it 3?
Because
No.
Oh, there is that final algebra. That's not a grade. It's just to see what you know. So you do it as fast as possible and that was not,
I got 3 minutes left because it kept on loading.
yeah, so just do it and that was not a grade. That's just to see what you know. So I'm not, so you don't get any extra on that one.
That's fine.
It's just like, I would kind of like to give like a mid thing just to see how we're, and then at the end, I'll give you that same one and see how you progress.
That makes sense.
And I will see you guys Thursday.